Okay, here in this lecture we will discuss about magnitude comparator. Before starting this topic, I am taking one example. Suppose there are two persons, one is X and another one is Y, and I want to compare the height of these two persons. So how many results are possible? There are three types of results that can be possible. First one, A is greater than Y. Second is first one is X is greater than Y. Second one is X is equal to Y. And the last one is X is less than Y. Okay, so if I want to compare the height of these two persons, so these three results can be possible. X is greater than Y, X equals to Y, and X less than Y. Okay, same case will occur if I compare two numbers instead of two persons. Okay, suppose if A is a number and B is another number, and if I want to compare the magnitude, if I want to compare the magnitude of these two numbers, so same as our first case, here also three results are possible. These are A is greater than B, second A is equal to B, and the last one A is less than B. Okay, now magnitude comparator is a device that is used to compare the magnitude of these two numbers. Okay, magnitude comparator is a combinational circuit that is used to compare the magnitude of any two numbers. Okay, so on the basis of magnitude, there are various types of magnitude comparator. Okay, now what is the mean of magnitude? What is the mean of magnitude? What is the mean of magnitude? Suppose I am taking two numbers A and B. Here A number is A equals to 1 and B number is B equals to 0. Okay, so in this case the magnitude of A is 1 bit, the magnitude of B is 1 bit. Okay, suppose I am taking another number A equals to 101 and B equals to 01. So here in this case the magnitude of A is 3 bits and the magnitude of B is 2 bits. Okay, so it means that the number of bits represent the magnitude. Number of bit in any number represent the magnitude. Okay, so on the basis of number of bits, there are various types of magnitude comparator that can be designed. Okay, such as 1 bit comparator, 1 bit magnitude comparator. First one we can say, first one 1 bit magnitude comparator. 1 bit magnitude comparator. In 1 bit magnitude comparator, A number is of 1 bit and B number is also of 1 bit. Okay. Second, 2 bit magnitude comparator. Second, 2 bit magnitude comparator. Okay, in 2 bit magnitude comparator, the number A is of 2 bits and the number B is of 2 bits. In this case, if I want to design any magnitude comparator to compare these two numbers, so at that time that comparator is known as 2 bit comparator. Okay, same as if I want to compare the number A equal to 1 suppose I want to compare two number A and B and the number of bit in A and B is 3 bits each, so at that time the comparator that is required is known as 3 bit magnitude comparator. Okay, so here first we will so here okay, so here we will study first 1 bit magnitude comparator. 1 bit magnitude comparator. 1 Bit Magnitude Comparator. Okay, so as we already discussed, to to analyze any digital circuit, we need a table. That table is known as truth table. Okay, so here I am making a table. Okay, so in this table, these A and B are input bit, and accordingly we will get three different output. First is A is greater than B, second one is A equal to B, and the last one is A is greater than B. ठीक, first one is A is less than B, second one A equal to B, and the last one is A is greater than B. So because here A and B both are 1 bit, so that's why only 4 combinations are possible, that are 0 0 0 1 1 0, and the last one is 1 1. So in the first row, A equals to 0, B equals to 0, it means that A equals to B. So in this time the other outputs are 0. In the second case, when A equals to 0 and B equals to 1, so B is greater than A. So which one is 1? This one will be 1, and other outputs will be 0. In the third case, A is greater than B. It means the third output will be 1 and the first and second will be 0. And the in last case, only A equals to B will be 1 and the first and last case will be 0. So by using these truth table, if I want to calculate the equation, so A is less than B, the equation for A is less than B, it means that this first output, in this only this one is there, so I will take the input combination with respect to this one, that means A bar B. So its output equation will be A bar B. In the second case, A equals to B. In A equals to B, for calculating the equation of A equals to B, I will check the second column. In this second column, this one is there, so I will take the first combination, that is A bar B bar. I will take first combination, that is A bar B bar. Okay, and one more one is there, so I will take the second input combination, that is AB. So here I will write AB. So what I can write here, A XNOR B. This one is the output of A XNOR B. And the last case, A is greater than B. This one is our final output. So in this case, only this one is there. So I will take the input combination with respect to these output. So this one is A B bar. So this one is A B bar. This one is A B bar. Okay, so these are the three output combinations. So on the basis of these equation, if I want to design a logical circuit, if I want to design a logical circuit if I want to design a logical circuit, so to design logical circuit, I will take A and take some wire. I will write here B and take some wire. Now I will connect NOT gate here and take some wire. Now I will connect NOT gate and take some wire. Okay, now our first output is A is less than B equals to A bar B. Okay, our first output is A is less than B equals to A bar B. Our second output, A is greater than B equals to AB bar, and our third output is A equal to B. It means A XNOR B. Okay, so these are our these are our possible output combinations. So how can we get A is less than B? So to take this A less than B, I am fusing one input here and then I will fuse here. So from this path I will get A bar B, because from this end I will take A bar and from this end I will take B. So and when I provide these input to the gate AND gate, so its output will be A bar B. And in the second case, A B bar. So from this point I will take A, and from this point I will take B bar. So when I provide these two input to any AND gate, so from this end I will get A B bar. And when I will provide A and B, it means that when I take A and B to XNOR gate, so from this end we will get output A is greater, A equal to B. Okay, so this one is the logic diagram for 1-bit comparator. Thank you so much.